Good morning student, welcome to lecture number 5. Today in this session we will discuss about REST pipeline hazards types. One is control hazards and structural hazards. In last lecture video we discussed what do you mean by pipeline hazards and how many types of pipeline hazards are there. In last video we discussed what is pipeline hazards. Pipeline hazards is nothing but any condition that causes a stall in the pipeline operations, or you can say the interrupt which is occur during execution of pipeline is called pipeline hazards. And there are three types of pipeline hazards. One is data hazards, structural hazards, another one is control or instruction hazards. And data hazards, what do you mean by data hazards? And data hazards occur due to the data dependency, and there is three types of data hazards. One is row, another one is var, another one is wow hazards. Okay, so let's come to the control hazards. So what do you mean by control hazards? So before we go through the theory, let's go through the example of control hazard, then we'll understand it better. So this is the example of control hazards. Suppose there is number of instruction is there, or you can say these are the address instructions or address of instruction or memory locations 12, 16, 20, 24 and and 36. So 12 in 12 address location there is a instruction is called what? BEQ, branch equal instruction, R1, R2, 36, another one is 16, and R2, R3, R5, 20, or this is the having instruction is R6, R1, R7, and 24 address locations add R8, R1, R9, and 36 location XOR R10, R1, R11. Similarly, here also number of locations are there and number of instructions are there. So in first instruction what happens? This is BEQ or branch if equal instruction. If branch equation means what? If R1 and R2 is equal, then it will jump to which one? No, the 36 location 36 address location, it will jump to the control will jump to 36 location. Listen again. If BEQ means you can say branch, look again, this is the address location 12 and where branching equation is there, means branch if equation R1 and R2 is equal, then 36 instruction will be executed. So what happened? If R1 and R2 will equal, then it will jump to which location? 36 location, and here R10 and R1 XOR operation will be performed here. Okay, so what happened actually? As per your pipelining guideline, first 12 instruction will be executed location 12, then 16, then 20, then 24, after the 36. But what happened here? In fast equations, in fast locations, if R1 and R2 will equal, then it will jump to which one? 36. This is called what? Control hazards. Means whenever branching instruction or jumping instruction will be there, then it will jump to the its corresponding locations. So it will create what? Control hazard. So it will create what? Control hazard. So next come to we can understand betterly by the example. Let's have a look to the example. So this is our program, and in RISC pipeline how many stages are there? 5 stages are there. One is instruction fetch, instruction decode, instruction execution, another one is memory access or memory execution, and in last one is what? Write back to register, write back to memory. And these are the clock cycles: phase 1, phase 2, phase 3, phase 4, phase 5, or you can say stage 1, stage 2, stage 3, stage 4, stage 5. So this is our program. In 12 location this is the equation, this is the instruction. In 16 location this is the instruction, and in 20 location this is the instruction, and 24 location this is the instruction, and 36 location this is the instruction. So in 12 location it is saying that BEQ, or you can say this is the branching equation, who is saying branch if equation R1 and R2 is equal, then it will jump to which location? 36 location. This kind of instruction are called branching instruction, and in this case what happen, it will jump to is 36 location. In 36 location, whatever instruction will be there, you will perform the operations. So let draw the space diagram of this program. So this is the space diagram. So so I told you, in RISC model there is 5 stages are there. So 12 instruction will be loaded into the pipeline, or you can say these instructions are loaded to our execution. 12, 16, 20, 24 all are loaded to our pipelining structure. So if in 12 locations instruction is loaded to here, and this is what instruction fetch, instruction decode, instruction executions, memory access or memory execution. After that, write back to memory. Similarly, when it will the 12 instruction, when it complete its first phase and jump to second phase, at the same time the 16 instruction will load into the pipeline. Again, when it will jump into the third stage and it will jump to the second stage, at the same time the 20 instruction is loaded into the pipelining. Similarly, when the 12 instruction jump to the memory accessing time, and 16 instruction is jump to the instruction execution, and third instruction is jump to its instruction decoded, at the same time fourth instruction will be loaded to the pipeline. Okay, so what happened? So when instruction 12, look here, in instruction 12 R1, R2 and after that R6. So instruction fetch is there, instruction decode is there. After instruction decode, it will execute the instruction. After executing the instruction, he is writing the memory or accessing the memory. At that time instruction 12 or instruction first instruction at the location 12 get a message that he has to jump 36 location. What? He has to jump 36 locations. Okay, so after writing this one, you have to jump what? 36 locations. But look, when the instruction 1, or you can say 12 location address get the information, I have to jump 33 location, or it is a branching statement. At the same time, rest 3 instruction is loaded into your pipelining. Rest 3 instruction are loaded into your pipeline. So but the instruction 12 location instruction has to jump which location? 36 locations. Instead of jumping the 36 locations, rest instruction are loaded to your pipelining, which will create problem, because we have to jump which locations, because after 12 location instruction, after execution of 12 location instruction, after execution of 12 location instruction, we have to jump 36. Instead of jumping 36 location, we are loading the instruction of 16, 20, 24 into our pipelining, which is create problem, because we have to jump 36 location. Instead of jumping 36 location, these are loading to your pipeline. So to execute this 36 location instruction, we have to stall these 3 instructions. So create a control hazards. So it will create what? Control hazards. So create a control hazard. So stalling is required. So what we have to do, if we want to execute 36 location, then we have to stall these 3 instructions. After that, after executing the 36 location instruction, then we can go for this 16 location, 20 location, 24 locations. Get it? If you not clearly understand, listen carefully again. I am telling again. Look, this is a program. Let's draw the space diagram. So when we draw the space diagram, so 12 locations space diagram is this one, and 16 locations space diagram is this one, 20 locations space diagram is this one, and 24 locations space diagram is this one. But so when instruction, assume that this is instruction 1, instruction 2, instruction 3, instruction 4, and this is instruction 5. So instruction 1 is in 12 locations. So instruction 1, when instruction 1 fetch is instruction, after fetching instruction 1, he will jump to what? Instruction decode. At the same time, instruction 2 is loaded to the pipeline. When instruction 1 is in the execution phase, instruction 2 is instruction decode phase. At the same time, instruction 3 is loading to the pipeline. When instruction 1 is in memory accessing time, instruction 2 is instruction execution phase, instruction 3 is instruction decode phase. At the same time, instruction 4 is loading into the pipeline. Are you getting me? But instruction 1 get to know that he has to, in first fetch or in first stage, instruction 1 get to know that he has to jump which location? 36 location. He has to jump 36 location. So there is a problem. What kind of problem is that? Instruction 1 has to jump 36 location, but 3 instructions are executed in pipelining process. So it will create a hazards. Because after instruction 1 we have to, or 12 location instruction, we have to execute which location instruction? 36 location instruction. Instead of executing 36 location instruction, we are executing 16, 20, 24 instructions, which will create a hazards. This is called what? Control hazard. To avoid this control hazard, we have to store these 3 instruction loaded into the pipelining. After execution of the 4th instruction or 36 location instruction, we can load this rest instruction into our pipelining. Get it, everybody? So this is the space diagram. So it is creating problem because after 4 stages, the instruction 4 get to know the instruction 1. After 4 stage, or in 4 stage, the instruction 1 get to know that I have to jump in 36 locations. Or you can say after 4 phases, the pipeline architecture get to know that it is a branching instruction. Which creating a control hazards. If the pipeline know before second instruction, that it is a branching instruction, then there will be no problem, or there will be no control hazards are there. Get it, everybody? So let's go through the theory, then you can easily understand. Look what is see here. As for the example, since the branch instruction decide whether to branch in the memory access or memory execution clock for the BEQ R1 R2 36 instruction. So what happened now? Since the branch instruction decide whether the branch is whether to branch in the memory access, means instruction क्लॉक साइकिल 4 में पता चलता है कि ब्रांच इंस्ट्रक्शन 1 का जो इंस्ट्रक्शन है वो ब्रांचिंग इंस्ट्रक्शन है. इंस्ट्रक्शन 12 लोकेशन में जो इंस्ट्रक्शन है उसको क्लॉक साइकिल 4 में पता चलता है कि ये इंस्ट्रक्शन एक ब्रांचिंग इंस्ट्रक्शन है. The 3 sequential instructions that follow the branch will be fetched and begin executed before BEQ branch to location 36 instruction. देखो यहाँ पर क्या हो रहा है ना, 4 स्टेज में ही पता चलता है इसको कि ये ब्रांचिंग इंस्ट्रक्शन है. सो इससे पहले ऑलरेडी 3 इंस्ट्रक्शन पाइपलाइन में एग्जीक्यूटेड स्टार्ट हो गया है. सो इट विल क्रिएट अ प्रॉब्लम. जस्ट स्टॉलिंग पाइपलाइन फॉर ईच ब्रांच इज नॉट प्रैक्टिकल. तीन जो इंस्ट्रक्शन है उसको स्टॉलिंग करना इतना पॉसिबल नहीं है और इट इज़ नॉट ए प्रैक्टिकल इन द सेंस. सो कॉमन assumption is branch not taken when assumption fails flows 3 instructions. So commonly we are assuming that there will be no branching instruction. अगर branching instruction अगर होता है तो हमें क्या करना पड़ता है ना, ये तीनों को फ्लश कर देना पड़ता है, ये तीनों को फ्लॉस कर देना पड़ता है. So here the branch penalty, look here, three instructions are flossing, here 3 instructions are flossing, that's why it is called what, branch penalties. Or you can say how many branch penalty is here, 3 branch penalties, because 3 instructions are flossing here. Due to flossing 3 instructions, the branch penalty is 3 cycles. Get it everybody? एक्चुअली यहाँ पर होना क्या था, देखो ये 4 इंस्ट्रक्शन है, पहले 12 एग्जीक्यूशन होना था, उसके बाद 16 एग्जीक्यूशन होना था, उसके बाद 20 एग्जीक्यूशन होना था, उसके बाद 24 एग्जीक्यूशन होना था, उसके बाद जाके 36 एग्जीक्यूट होना था. तो इसका मैंने स्पेस डायग्राम यहाँ पर बनाया. जब स्पेस डायग्राम बनाया मैंने, इंस्ट्रक्शन 1 जब लोड हुआ पाइपलाइनिंग में, तो ये पहले फेज कंप्लीट करने के बाद सेकंड फेज में गया. जब सेकंड फेज में गया इंस्ट्रक्शन 1, तो ये वाला इंस्ट्रक्शन पाइपलाइन में एग्जीक्यूट हो गया और लोड हो गया. फिर जब ये थर्ड स्टेज में गया और ये सेकंड स्टेज में गया, ये वाला इंस्ट्रक्शन यहाँ पर लोड हो गया. जब ये फोर्थ स्टेज में गया, ये थर्ड स्टेज में गया, ये सेकंड स्टेज में गया, 24 वाला इंस्ट्रक्शन यहाँ पर पाइपलाइन में लोड हो गया. देखो फिर 3 इंस्ट्रक्शन लोड होने के बाद और अपना अपना काम करने, ये तीनों अपना काम करते रहते हैं, कर रहे हैं. उसी टाइम पहला इंस्ट्रक्शन को पता चलता है कि ये ब्रांचिंग इंस्ट्रक्शन है, तो मुझे 36 लोकेशन पे जंप करना है. तो अगर मैं 36 लोकेशन में जंप करूँगा तो ये सब कैसे जंप करूँगा, तो इन तीनों का ऑपरेशन को मुझे स्टॉल करना पड़ेगा. इन तीनों का ऑपरेशन मुझे स्टॉल करना पड़ेगा. उसके बाद जाके मैं 36 को यहाँ पर पाइपलाइनिंग में लोड कर सकता हूँ. तो इसको कैसे स्टॉल करूँगा, और ये जो प्रॉब्लम होता है ना, ये जब उसको पता चलता है ये ब्रांचिंग इंस्ट्रक्शन में है, ये एक ब्रांचिंग इंस्ट्रक्शन है, ऑलरेडी ये 3 एग्जीक्यूट हो रहा है, तो इसको बोलते हैं कंट्रोल हजार्ड्स. सो ये कंट्रोल हजार्ड को ओवरकम करने के लिए उसको क्या करना पड़ेगा, इन तीनों को स्टॉल करना पड़ेगा. लेकिन ये प्रैक्टिकली पॉसिबल नहीं है, तो ये क्या करता है, ये तीनों को ये फ्लश कर देता है. क्या कर देता है, फ्लश, और यू कैन से डिलीट कर देता है, और 36 इंस्ट्रक्शन को यहाँ पर एग्जीक्यूट करता है. उसके बाद इन तीनों को एक एक करके एग्जीक्यूट करता है. सो टू फ्लॉसिंग दिस 3 इंस्ट्रक्शन इज कॉल्ड व्हाट, और फ्लॉसिंग दिस इंस्ट्रक्शन आर कॉल्ड व्हाट, ब्रांच पेनल्टी. एंड यहाँ पर कितना साइकिल्स को हम प्रोसेस कर रहे हैं, 3 साइकिल को. सो इट इज द ब्रांच पेनल्टी इज व्हाट, 3. गेट इट एवरीबडी? सो व्हाट डू यू मीन बाय कंट्रोल हजार्ड्स? द इंस्ट्रक्शन फेच यूनिट of the CPU is responsible for providing a stream of instruction to the execution unit. The instruction fetch unit of the CPU is responsible for providing a stream of instruction to executing unit. Here the CPU or the instruction fetch unit is the responsible to know the CPU whether the instruction is having branching or not. The instruction fetched by the fetch unit are in consecutive memory location and they are executed. Obviously instructions are executed in consecutive memory location. After that problem arises when one of the instruction is branching. So problem is arise when the CPU get to know that one of the instruction is a branching instruction. In this case, all the instruction fetched in the pipeline for consecutive memory allocation are invalid now and need to removed, also called flushing or the pipeline. Look here, when the instruction consecutive locations are read by the CPU pipelining process or the CPU, so when he get to know that 12 instruction is what is a branching instruction, then he is flushing these 3 instruction. He is flushing this 3 instruction. So this is called flushing of the pipelining. This is called what, flushing of the pipeline. So next, thus the time lost as a result of this called branch penalty. Look, so in this case all the instruction fetched in the pipeline from consecutive memory location are invalid now and need to removed. This cause a stall in pipeline till new instruction are again fetched from the memory address specified in the branch instruction. Thus the time lost as a result of this is called a branch penalty. So for reducing the resulting delay, dedicated hardware is incorporated in the fetch unit to identify branch instruction and compute branch address as soon as possible. So look this point carefully. For reducing the resulting delay, dedicated hardware is incorporated in the fetch unit to identify branch instruction and compute branch address as soon as possible. So what he said, he said that there will be a dedicated hardware joined with the fetch unit which is recognize whether a computer address or whether a instruction having a branch instructions. When the pipeline get to know as soon as that instruction is a branching instruction, then he will easily sort out the problems. There is no need to be flaws, there no need to be stall the pipelining executions, and this is the process through which we can avoid the control hazards. How we can avoid the control hazards? We have to join a dedicated hardware with fetch unit to get whether the instruction is branching or not. So what is control hazards? If our execution is continuing like this, but some after sequential execution of some instruction, one instruction is jumping to directly to new instruction. So in this condition there will occur what? Control hazards. So control hazards means when control hazard occurs, basically control hazard occurs when branching instruction is there. When control hazard is occur, we have to stall the rest instruction to avoid the control hazards, or you can say we have to flossing the pipeline to avoid the control hazards, and by the help of flossing the instructions, we can normalize the execution of a pipelining. Or you can say we can control the control hazards by installing dedicated hardware with a fetch units. So this is all about your control hazards, and and there may be a question asking the BPOT, what do you mean by branch penalty? You can say the time lost as a result of this, or you can say the caused a stall in pipeline till new instruction are given fetched from the memory address specified in the branch instruction. The time lost as a result of this is called what? Branch penalty. Maybe a problem is given to you and he will ask for you find out the branch penalty. So easily you can identify the branch penalty. Just you need to write the program carefully. After writing the careful program, you have to draw the space time diagram. When you draw the space time diagram, easily you can get the branch penalty. So this is all about your control hazards.